Hey, what's going on, folks? It's Mike here, and welcome back to my deep programming language series. In today's episode, we're going to be talking about opApply. Now, opApply is one of the coolest features in the deep programming language, but it's one that's taken me a little bit of time to wrap my head around, so I just want to go ahead and talk about it, show some examples, and try to give you some intuition about how opApply works. Now, opApply is related to what we've been talking about with iterators and iteration in the deep programming language and ranges and these types of things. But what's really cool about opApply, it is just one function. So let's go ahead and take a look here. And before we dive into an example here, let's just go ahead to deep programming language and get a little bit of a sense of what opApply is. So I'm going to take you to two different locations here. One, I'm going to take you to the D language tour, and then I'm going to take you to the documentation here. So let's go ahead and just see what opApply is. And again, this is going to be under, I believe it's under dgems here. Yes, it is here. So opDispatch and opApply. So opDispatch we've already talked about, so make sure to check out the playlist previously for that. That's sort of this catch-all function if we have on a struct or a class some member function that we don't have, but we have opDispatch, then we can sort of catch it. But opApply is doing something a little bit different. And again, this has to deal with foreach statements. So go ahead and read it off. opApply, an alternative way to implementing a foreach traversal instead of defining a user-defined range is to implement an opApply member function. So that means I don't have to create some separate type for a range or for my data type, worry about implementing things like empty, popFront, front, and so on. I just write this one single function. So iterating with a foreach over such a type will call opApply with a special delegate as a parameter. And it's important to note if you do have this range implementation, some user-defined type like we've been talking about, and opApply will be the favored function in a foreach loop. So for instance here, this foreach node tree here, so again, this has to deal with a foreach statement for opApply. It's going to call this opApply. Even if we had some range called tree in this case, it'll still favor, if it finds both, this function. Okay, so that's one thing to note here. Now, let's actually see or try to gain an intuition as to exactly how this is working. And I'm going to go ahead and just copy this snippet here so we'll have something to work with. But the important part is here. The compiler transforms the foreach body, so that's here, whatever we would put here, to a special delegate that is passed to the object. Okay, so opApply, you'll notice, takes this delegate here. It's one and only one parameter will contain the current iteration's value. Okay, so in our foreach loop, we've got node. And well, it looks like in our delegate function here, we just have one element here, and that is tree here. Okay, so a tree, I suppose, has a left and a right branch here. I might call this binary node or something in our example, just to help make sense of it. But that's the basic idea. So this delegate here, which we talked about delegates in the previous video, and I've touched on them a little bit before, again, is taking in every time we sort of call this opApply function node. So each iteration, each element of our loop is being passed in here. And then it's executing that body within our opApply function, okay? All right, so the magic int return value must be interpreted, and if it is not 0, the iteration must be stopped. Okay, so we're going to notice that there's going to be sort of this magic return value here in this example. Okay, so let's look at a few examples. Let's work with this one that is provided, and then we'll dive in a little bit more here. Now, as far as the other specification for opApply, I believe it's under statements here. And we're going to find this under foreach statement. So let's see what we got here. I think if I just search opApply, here it is, number 4 here, just to give you an exact location. There we'll have opApply. So again, we can see how this works here. Okay, now we'll talk a little bit about this example and some of the other examples in opApply. And there's, of course, opApplyReverse if you want to iterate in the other order. So again, I'll just make a mention of that, and maybe we can take a look at this example as well. But let's go ahead and just work with this tree example here, just to have something to work with, something that is working. I'm going to go ahead and move this tree here. And as I mentioned here, I think a better name for tree here, I'm just going to call it let's just call it binary node here. That just makes a little bit more sense for me. And we'll kind of make this our own example here a little bit, okay? So anyways, a binary node, it is a class type here. So that means we have referential semantics. So again, you know, I need to initialize the left and the right-hand side here, etc. But that'll be the idea. And let's give ourselves just a little bit of data to work with here, just so we can actually perform an iteration here. Let's call this root. And again, I want to make this example my own just a little bit here. Let's also give some data here. And let's give the data as a string here. And I'll just put in some, you know, I don't know, data or something here, just for a default here, okay? And what I want to do here is create a few, let's do root.data equals root node, do something like that. And let's create a few more nodes here. Let's call this the left-hand side and the right-hand side. And the root left-hand side will equal left-hand side. And the root right-hand side will equal right-hand side. So something like that. And we could initialize these. Let's see. I believe this will work here. And let's make sure that we can compile this. Let me just go ahead and show you the full snippet here. And I'll go ahead and put like right line here, node data, something like this here. Okay, let's see if this example works. Oh, let's see here. Tree, I renamed that to root. Darn it. I thought I was going to make it in this lesson without any mistakes, but there we are. So anyways, we can see that this is working. Let's go ahead and just draw what we have here, just so you can visualize the data structure in case trees aren't very familiar with you. I'm thinking about doing more data structure lessons in the future, perhaps in D or C. So anyway, stay tuned for that. But okay, so we've got this binary node structure, or it's a class rather. And that means we need to use things like new to again instantiate it. And it's got a left-hand side, a right-hand side, and some data here. Okay, so 3 fields available here. Okay, and in my code here, I've got the root. Oops, let's see if we can make this stick to the top here. There we are. And then I'll have my terminal there. Okay, so anyways, our node here, our root that we instantiate on this side here. And then I got my left-hand side and my right-hand side. So I'm simply just pointing the left-hand side to our left-hand side and then our right-hand side here. Okay, so just a binary tree like data structure here. That's the idea. Now, is our traversal working correctly? Okay, so how are we doing this? Well, let's look at our opApply function to understand what's going on. So we're going to get to this delegate function in a moment here, but let's actually see what the sort of algorithm is. So remember what we're doing here is we're looking at one element at a time here. Okay, so the first traversal through, we are passing our root in, okay, because we're iterating through root. That's this object, binary node. Here it is at line 16. And we're going to call this function. And it's going to check the left-hand side. Okay, so make sure it's not null. So we have something here. And then we'll apply left-hand side delegate here. Okay, and then return 1. Okay, so basically what we're doing here, the very first thing in our traversal is we're saying, hey, pass in our root node, which is taking place here. And then look at the left-hand side. Okay, so we're going down here for our traversal and grab this guy here, left-hand side. And then what we actually do, well, what are we writing out here? We're writing out data. Okay, so maybe we can make this a little bit more clear here. Let's go ahead and, this is going to be a little bit ugly, but I want you to see everything else. Let's just make our data left-hand side, and for right-hand side data will equal right-hand side. Don't write your code like this with multiple statements in a line. But for the purpose of keeping everything on a screen here, I think this will be okay. If I do it correctly, that's 2 mistakes. But now we can more clearly see, again, left-hand side is our first node that we visit, because that's the first thing we have here. And then we call opApply. So we're doing our iteration. We've sort of moved, in a sense, our iteration to just this function. This function here, opApply, is telling us how to do the traversal. And then the actual work that we're doing in the traversal, well, that remains in the body here. And that's sort of where the magic comes in at opApply, because this part here, right line, somehow gets moved in. I mean, we could effectively think of this as popping up here and, pasting it in somewhere here. I'm pasting in, effectively I'm pasting it in somewhere like this here, okay? The body of the for each statement comes in here. That's a compiler transformation that does it for us. Now, there's not a great way to really see this other than dumping out the assembly. You can kind of see this. In fact, we'll do a little bit of an investigation because I was investigating this as well, and it might be interesting for you. But that's sort of the mental model to keep in mind for using opApply. You don't have to necessarily understand all the internals, but the internals are, this is telling me how to do the iteration. 1 sort of means continue forward. 0 sort of means, hey, we're done with our traversal here. And then if I call on the left-hand side, I could still call opApply, right? It is just a regular member function. It's a special member function, but I can still call opApply. That's of the same type, binary node here. And then I pass in this same delegate here. And again, what's the delegate? Well, that's where that magic transformation, from the for each loop that holds the work here, this right line here. Effectively, again, maybe the right way to think about this is for me to copy it and almost just paste it in here, something like this here. Whoops. Let's see, it's gonna make it a little bit messy here, but let's do this here. Just again to give you a visual here. I'm gonna just like paste it in here. Oops, let me do paste. And I'm just gonna put it in a comment. Again, this isn't the 100% right way to think about it, but again, it kind of gives you a mental model of what's going on there. So anyways, that's kind of right, our delegate, the thing that's doing the work here. And the arguments to this delegate, a 1 binary node, well, that's coming in from here, node, okay? Now I could have something like, if I want to do this, and we'll look at this in the documentation, if I have 2 values here in my for each, like a key and a value, well, then I'd have 2 parameters here, okay? And this is the basic idea. And again, usually it returns, an int here as well to match opApply. Okay, so that's just a little bit about how it works. I'm going to get rid of that right line because it looks a little bit ugly here. But again, hopefully that gives you the idea of what's going on. Okay, so anyways, as we do our left-hand side traversal, we'll notice there's no left-hand side for our left node here, right? The binary nodes are both null here, right? There's nothing here. This would be, null and null. And same for our right-hand side, null and null. So how does our traversal work? Well, then we look at our original object. So effectively, we go back up to our root. That's what was printed out, root node. And then again, we sort of repeat the process here, and then we got to visit the right-hand side of our original node, and then go through here. So just like that, in 3 lines, 4 lines really, because you have this return here, you have a tree traversal, right? And you can switch these around however you want. But that's pretty powerful. That's pretty cool. Okay, so that's opApply, and that's again sort of the magic that is happening here. Let's do one more example just to kind of make this a little bit more concrete, and then maybe just show you a different iteration pattern. So what I'll do is let's just comment this out here. I'm going to use these new style comments because I like this in case I need to nest comments for anything later here. Let's just basically get rid of all this for now. Let's just hide it there. And let's just hide that as well here. Okay, so let's go ahead and do another example. Let's just do like an array here. Okay, so I'm going to do an array. We should hold some, I don't know, data or something, internal array, something like that, let's say. And then let's implement opApply. So opApply, and then it needs to have this delegate function here, and we need to decide, what the parameters are. Well, let's go take in something t. If I want to modify it, I could do ref t even. So let's go ahead and do that. And then the basic form of this, as you'll find in examples. Let's see if they have a nice example here. Doing for each, let's find opApply. Just so we could kind of go from the documentation as well here. Let's see. Okay, so here's like the very basic one here. Let's see here. Yes, this is what I'm looking for. This sort of pattern here. Okay, this is going to be pretty similar to what we have here, but I'll show you the pattern. So again, opApply, what's it do here? Okay, I've got this code here. It's a for each, a here, which is of type foo, Okay, foo implements opApply, so this is the function that we're going to do. And again, remember, the job of opApply is to basically take charge of our traversal. Okay, so I can basically move the foreach here, and the foreach is going to, again, iterate through everything. I mean, we did that previously, right, with our tree. Let's go ahead and just open this up for a moment here, right? We did that here. It was recursive, right, a recursive implementation, but we did our iteration through here, okay? Just like you would have coded this, you know, a tree traversal in its own function called DFS or BFS or something, right? So that's the basic idea here, okay? Okay, let's see. Oh, what did I do here? I created a little bit of a mess. Okay, so let's go ahead and hide this guy again, just so, again, we have only a few things to work on. So again, my basic iteration for an array is going to look like for each element in our, you know, internal array here, do the work. What is the work? The work is whatever the DG is, which is this delegate function, okay? And DG is a magic, I don't like the word magic because we're trying to figure out how things work here. A special compiler transform that effectively takes the body of our for each loop. Okay, so that's all it's basically doing, right? So again, that was the point of, you know, this is telling us what's the work we're doing per element. Okay, the same thing that we would have in a for each loop here that says, well, let's create our array object of int. I don't know, let's just call this ints or something. And then let's have ints internal array. Okay, maybe if I name something internal array, this should be private or whatever. That's a different discussion. But let's just make it something, you know, reasonable like this here. And then let's just say for each element. And instead of having to do something like ints.internal array, right, which is kind of ugly, you just pass in the object, right? Because the object, ints, which is of type array, and I made this a template here just to review something here, right? It has this opApply function. So there's the beauty of it, in my opinion, of opApply. I don't have to do like ints.getInternalArray or any of that, you know, yucky stuff. I can just implement this opApply function. And it's only one function, which is nice. I could have helper stuff as well here, but, you know, it's just nice to have everything in just one function. Okay, so let's go ahead and continue on with this. Let's go ahead and finish our loop here. Let's see if this much compiles here. Let's see here. Array ints. What did I mess up here? Has no return statement. Oh, okay, so I just have a finished thing. And let's just say here, template. Okay, it's having trouble instantiating, probably because I didn't have a return statement. Okay, so what I'm going to do for my return is I'm just going to store a result here. And let's just return result. Okay, if it makes you more comfortable, you can set result to 0, but remember in D, values aren't initialized to 0. So, you know, you don't have to worry about that. And there we go. Let's go ahead and run this now. Okay, so now it runs. It doesn't quite do anything interesting yet. Let's do the same kind of thing here. Let's write line element. And just to show that we're doing a little bit more work, let's just go ahead and say element, you know, colon or something like that here. Okay, so it's not iterating yet here. Okay, but it's going to take this right line, apply it in here somewhere, and print it out. Now, why didn't I print it out? Because I told you that, you know, basically, you know, basically what I'm doing is copying and pasting in this right line into this body here. Are we doing any work? No, because remember, that's this guy, this magic guy here, DG. Okay, so what if I call DG in here, which is doing our work? DG on our element here, maybe something like that here. Ooh, neat. Okay, so all of a sudden, this guy here, DG, which again is taking in our work here, is printing out here. Okay. Now this worked, which is kind of interesting here. Okay, so let's study this a little bit here. I mean, it works nicely, sort of in isolation, because you know, we iterate through everything and then we return the result, which we had to return something here, and result is 0. What if result is not 0? Something like that here. Okay, it still works here. So that's kind of interesting. So that kind of, again, teaches us what, how this works or whatever. But let's look just a little bit more at the documentation here, because if we look at the documentation, we'll see pretty much the same or very similar example here for a class. In this case, we used a struct here, but it has an internal array. We iterate through it, but then it's got this stuff here. If result, return result, and then, it's got something here. Okay, so what all does this mean here? Well, let's see if we can find some pointers here. I think I'll point you to here for now. It says the body of the apply function iterates over the elements. It aggregates, passing each one in successive calls to the delegate. The delegate return value determines whether to interrupt iteration. If the result is non-zero, apply must cease iterating and return that value. And then this says, if the result is 0, then iteration should continue. If there are no more elements to iterate, apply must return 0. Okay, interesting. Okay, so maybe we have an interesting sort of structure here where we basically want to say, this returns 0. Let's keep our documentation up. Sorry, this is a new Ubuntu feature. I don't know if I like that keeps one or two windows at the top. There we go. Anyways, so if I have this result thing here, let's look at the structure here, because I kind of like the structure in the documentation, right? Return 0 means we finished here, right? It's very clear in this struct to iterate through it, which has all of these elements here, right? We just want to return 0, which if the result is 0, then iteration should continue. If there are no more elements to iterate, apply must return 0, okay? So if I make it through my little for each loop, I can just make this 0. And again, if it makes you more comfortable, you can just use a regular for loop here and do for, size t equals 0, right? If it makes you a little bit more comfortable to do something like this, I equals 0, I less than internal array dot length I plus plus, something like that. That's also fine, right? It's not illegal. I know since we're talking about for each, which has these special capabilities, maybe it seems a little bit more scary. So you're welcome to do that. But now let's work on this part here. So okay, so this is again basically doing our work here on each element, and the delegate, it has a return value of int here. So I can do a result equals something like that, okay, which is what the documentation is mirroring here. So let's do int result equals that. And then we're checking the result here, okay? Because it says if the result is non-zero, apply must cease iterating and return that value, okay? So let's kind of mirror it. If and let me make sure the comments are in order here. And this is going to be determine if we should cease execution, okay? So if result, and I like using curly braces. I know some people think they add to the noise, and in some ways they do, but so if result, return the result here. Okay, so if this is non-zero, okay? I mean, the only possibility I basically have in this, and that's a little bit of a weird example. Let me get rid of this here. And let's just, I'll just leave this here. But it's a little bit of a weird example because I'm doing all the iteration here, but let's just see what happens if I say, okay, I'll do one round of iteration. Let's just always set the result to 1 here, okay? What do you think is going to happen? Are you going to get 1, 3, 5, 7, and 9? No, right? Because the result was non-zero. So somewhere here I could check if the value is 5 or something, because maybe that's a sentinel node, meaning like a terminating node in whatever the structure is that means stop, right? In the same way that we have a null terminating character, okay, which you might use. Or a node that is null in the case of you're iterating through a tree, like the tree traversal, okay? So anyways, that's how opApply works. It's a little bit of magic, so to speak here, but the cool thing is about opApply, I think it's cool. I haven't seen this in many other languages, maybe like Lisp or something. There are apply functions, and let me know if there are other apply functions that you've seen. I'd be curious in programming languages. Even though I've looked at a lot here, this isn't one I'm trying to remember offhand if it showed up, but this really was a unique thing, at least when I started learning D here. And to use it is very easy, but hopefully in this video you kind of understand it, what's going on in the form of it. But again, I think it's neat because it's just one function. It makes your interfaces sort of clean, right? If I want to say, well, I have an array of this thing here, let me just iterate through it. I don't want to have to know about this or write a getter function for an array. I just have opApply and it kind of works. And what might be a useful exercise if you want to go further with this is to look at maybe the Phobos code or some other library code just to see other examples of opApply. But basically anywhere you've done a tree traversal or written a function like a depth first or breadth first search or something, right? You can put that type of thing in an opApply. And if you have a tree-like data structure or a graph or something, you can handle this. And you can have overloads as well for different types or these types of things here. Now, the last thing I'll go ahead and do here is just show you an example. I think there's let's see. Yeah, you can template this. So, again, you can have a lot of fun with this. Let me see if there's an example with keys here, because you could do this over a associative range as well here. Let's see here. Because basically what I want to show you is the delegate could have multiple parameters, which I don't know here if there's an example. Maybe there's an example here. I guess not. I'll just tell you what it is. If I have, for instance, something like this element, and what if I have something like int index? Let's just do this live for a second here. Okay. And let's go ahead and print this out too. IDX, and then I'll put, I don't know, another comma here. Okay, let's see what happens. Okay, this is gonna say cannot infer argument types, expected 1 argument, not 2 here. Okay. Okay, no problem. Let's go ahead and scroll up here. So let's go ahead and say, what if I have a index here? Something like that here. Oops. And then my delegate I need to also power up here. Let's go ahead and just pass in, I don't know, 0 or something, just to see what happens. Oh, cool. This takes in the value that I'm iterating. And let's get rid of that here. And now, right, I can take in IDX that slots in here, element that slots in here, which is just an integer element of our internal array. And that's what's being passed in, again, to our delegate function here. Now, to truly match this, just to make this a working example, I should probably pass in, I don't know, we should probably have some like counter or something here. And then pass in the counter. Let's see if that works here. I think I need to give it a type. Make it an int as well. Or did I make it a size t? Oh, size t. Oops. Or u long. Let's see here. Yeah, I might have messed up the types here a little bit. Okay, I had the warnings here, but you kind of get the idea here. Let's see. Foreach loop implicitly converted from size t to int. Yeah, okay. So these should all be okay. Here, let's do this properly. Anytime I have an index. And then this video is already a little bit long, so I want to go ahead and make sure that we wrap it up here too soon. All right, no warnings. There we go. So anyways, there you can see that we're able to, again, pass in. I mean, if this was, I mean, this is effectively the key and the value here for our iteration. It just happens to be an array here, but you can see how to pass in multiple types. You can have this templated, so it really is, it's got all the tools that you might need here. What kind of things might I put for a template here? Maybe like the policy or something, right? You could have for how you want to do this iteration. Do you want to skip every element or something, or every other element? In a tree traversal, you might have different policies for, again, doing a pre-order, in-order, level order, etc. traversal. So again, you can use your imagination there. Anyways, folks, I'll go ahead and scroll through the code here as we wrap this up, right? We did our little binary node example that we adapted from learn D. And then we did our second example here with opApply and this custom type here. So you can see 2 different ways to mess with opApply. And I mentioned this at the start. You know, it's kind of hard to see the transformation. So you can run this with VCG AST here and get the actual, let's see, the call tree or call graph here. Which again, we've looked at in a few previous videos, so you can search through my playlist if you want to see that. And that'll give you some insight if you look in the main here that, I mean, this is the main thing that I want to show you, is that this here in main here corresponds to, you know, what I have here at line 43, 44, and 45. You can see that this loop here, this for each loop, got transformed into this call. Okay, that's the main insight, again, just to understand a little bit of the internals of what's going on, that, you know, I don't see a for each loop in my main here, okay? And you shouldn't either, right? In this block of code here, there's no for each loop, but clearly I've written one. So clearly we can see there was some transformation here that's calling our special, you know, opApply function that we've defined here, which is going to do the iteration here of our for each. Check the result, and again, it'll tell us if we return, if on some condition, you know, that we specify that's being returned, the return code, whether or not to continue iterating. So anyways, I think that's pretty much all I can show you about opApply. I think that's pretty much all there is. You can go ahead and play around with this as a little exercise if you want to test yourself, right? opApplyReverse as a second function, and then call foreachReverse, just so you can see if you've sort of mastered this, and you can try to do it from scratch after watching this video. So anyways, folks, with that said, I would encourage you to check out course.mshot.io. You know, check out the course here if you're not already watching it. Feel free to join in the community to discuss what you learned about opApply, and leave a review if you're enjoying the D language lessons on courses.mshot.io. Otherwise, I'm just grateful that you're watching this on YouTube or wherever. And I want to, again, thank you for your time. Hopefully you learned something new and are having fun with the D language. This is really one of the more advanced features, I would say, but it's relatively easy to use, so to speak, once you wrap your head around it, or if you're pretty familiar with algorithms, it'll hopefully click for you. Just play around with it, try some of the samples, and you'll get it. All right, folks, thanks again for your time and attention, and I'll see you in the next one.